because this is our specification. These names sound familiar to you? Do you recall this name from somewhere? These are the name of the functions. Yeah. So we come to the point that function equals to what? Device. So every function is a logical device. And then if we open distance, now we have 4 zones. And normally the P, this is the logical node. Where is this zone 1 coming from? This is the prefix. I said we can add some prefixes, right? Because maybe the contractor would say they come from maybe the bigger number. They would, yeah, normally you don't, but they make this zone 1 here, and then zone 2. I mean, to make sure really, to make sure that zone 1 is zone 1, they use the P, this one as zone 1, okay? Yeah, just, you know, you can do everything. Or it's good for you that you know this is PC. I don't want to memorize this. I know that this is teleprotection. Just add some text. And this is teleprotection. Okay, then we have some data objects, and then we have the boss who has this LPHD, and then we have some diagnostics. What's LCCHD? Yeah, you see, I forgot to write what's LCCHD. I mean, ID's code shows you in the description, but you can also open this description and move out to monitor, then you have more information. But theoretically, I would write here the communication supervision, consup something. Okay, let's look to Bay controller. And even there's no IP address, you see. Nothing defined. On the data model. It's more the control functions CSWI, XSWI, cycle1, auto reclose. I don't know why I put recloser to here. Maybe recloser for me, and because there are different flavors, right? You think that it's design issue at the end. You think that auto-recloser is an Bay controller function, but I think that auto-recloser is a protection function. Could be. Could be that distance sends a signal, so protection sends a signal to Bay controller as a goose, and then Bay controller makes the close. It can be. I've seen this. Yeah. Okay, so we have 2 IDs, and then we know what to do. The contractor knows how to create this data model, but now he needs to do something else. So I will skip just to use time efficiently to really just give some maybe. Okay, I will show how to give a setting, yeah, protection setting, because here, if you go to protection, you will see maybe our protection has a setting, a start value. Yeah, maybe here can give a setting also. That you need to define in data type templates and settings start value. Here, if you go to PTOC, then you need to define the where is it? Operation time here, the set value, and then it will add this value. And then if you go to now the IED, you can set this time. Okay? That's how you add. And then the communication services, I will just show very quickly how to add goose, report sample values. For instance, you want to add a goose. Okay, how do you do this? You go to our goose report. We select the IED, then we have these icons. Now I want to create a goose. I click the goose. I add one goose. Say something meaningful, position, and give a good ID, position goose. Next is now defining the MAC address. As I said, you can define everything, then the contractor doesn't need to think about what shall I do. They don't think about just. And then maybe the minimum time, this is for you maybe important function, then you have the goose with 2 milliseconds minimum time. Maybe it's a trip goose, something else. And then you have the, well, this is protection. Yeah, okay. Forgive me. Imagine this is a trip goose, okay? Then we say overcurrent, then we go to here, operate, general, and Q. Don't forget Q, okay? Always add Q also, and you add a steps. Good, now we have a goose. That's that much easier. And the same you can do for the report. Okay, and Remember, we had no goose, no report, okay? But when you do this, now what happens is now you have report, okay, I go to this view, no, not this view, I have a goose, I have some positions, like this, okay? I have some position of all every space. This is just specification. Yeah. The same I did for reports for protection. Protection has a report, he's sending out a report of trip. Maybe I close the description, you see it better. Operate general, Q operate general, stage 1, stage 2. Okay. Now I define that a goose will be sent out when there is a protection over current trip, stage 1. That was the next, okay? Then, yeah, we need to assign the logical nodes to substation section also to really show it like this, but I will skip this for the moment. And then go to validation. You know, we need to validate. It's so easy to validate. Just say validate schema. Where are you? Validate schema. Then it's successful. Also validate the templates. Then no error. But now we have a good SSD file. And one hint is OpenSSD always saves with SCD format. Okay? It says that when you say save, it will save with SCD. Don't worry, it's just a name, okay? Change it to SSD. The content is SSD. Okay?
Burak, can you go back to the use creation on the selection of the destination MAC address? So, what are the choices that we have? So you only have the multicast.
So this is defined by standard. It doesn't say must, but it say the standard doesn't use the must word. It uses like shall be strongly recommended blah blah thing. Okay, this is the same, but here you have the freedom to select. Better, my recommendation would be like protection would be 0.2, position would be 0.1. Based on the application you make, you give a separate name. Standard says doesn't have to be unique, but strongly recommended to be unique, he says. Okay, this phrasing he uses. I would, in my engineering, we say that we support engineering. In my engineering project, I use this kind of application ID with MAC address like this, same, because it's a 4-digit number. For different applications, like 3 different MAC address, we can also give 0.1 to all of them, okay? What happens at them? Nothing, it works. Standard says recommended, highly recommended, but I don't care about standard maybe, okay? Because it doesn't say shall. Shall is a must to have, then the tools doesn't verify, but here you can have 0.1 for everything. It's fine. The idea behind having unique MAC address and application ID for each application, it says application, right? For each application is then you can filter them out in the space. Yeah? You don't want your trip to go everywhere in the substation maybe. Does it make sense, for instance, for line bay trip goes to medium voltage base, for instance? Yeah, they don't need it. Why the trip is hanging around in the substation? We make a path to our trip. Trip only goes to where it needs to go, not everywhere else. Okay, we need to filter. The 650 multicast MAC address is a mechanism that goes more or less everywhere, but we don't want. Then we want our cable only connect to the correct place. Okay, that's the thing. Did I answer the question?
But it is still a multicast address.
It is multicast address.
It's different multicast address.
Yeah. Normally it should be different. It's not the source MAC address. Source MAC address is something in the Ethernet interface. Okay, here this is the source MAC address. It's stamped in it. It's really in the manufacturing stage. It is really stamped on this. You cannot change in legal ways. Okay? Illegally you can change, but you cannot change. It's like every car has a nameplate number, right? Chassis number. It's like this. Good. The last thing, we come to the end. We created our dream IDs, which is nice. And then maybe we open it with Station Scout to see this communication is also as we made it or not. And then we deliver it to project engineer. Okay? So at the end we will have a substation like this. And we have two IEDs, and they are, one is sending a goose, you remember? A controller was sending a goose, the position goose. You see the positions? And protection was not sending a goose, he was sending a report. What was the report? Orchard trip 1. Stage 1, stage 2. Okay, this is how our dream bay now looks like, or specification. The other base has nothing. Yeah, they are question mark at the moment, just because there is nothing in. Okay, any questions until now? It's not so difficult. First time everything is different. I repeated this 100 times before I come here, that's mine. It was also difficult for me, but I made some rehearsals. Good, now we need to go to market. What's the task now? So we have a shopping list. My wife gives it to me generally, and then I go to market. Okay, this is what she wants from me, but this is what's available in the market. Yeah, generally it doesn't match. Even if it matches, I come back home and she says, "Ah, it's not that one." We need to check if the dream IED is matching with the market. Yeah, is there a physical IED available? So we will use Siemens for this purpose. Yeah, just because we have Siemens, but normally you should also check. Yeah, maybe Siemens got a project. In Dixie there's a function. Yeah, it's nearly a hidden function. It says import specification. Okay. So we will import this specification of our IED to a physical box, and then this physical box, it's blue. Why? It can be any protection, whatever. And then it needs to adapt the data model according to my wish or my desired data model. Let's do this in the remaining time. So I just close this project. I will open, like everything, I will start from scratch. So I'm the project engineer, the utility, we got a new project. My boss told me that this is your project, now find an IED. Okay. I create a new project. Then, you see there's nothing here. You go to import specification, and you import the file that you created. That's this file. Okay. Let's make this bigger. Bigger. Even bigger. So, no match found. Why? Because there is no IED in the project. Now I look to the shelves in our warehouse, what IEDs can be used in, look to this IED. I have the default, factory default file of this IED. I will add this device. Sorry. Not add device, but import this device file. That I have text file. It's just default file of protection IED. Normally I don't have any transformer protection, but this is a transformer protection. But I have a line protection. No problem. Yeah, sorry it takes some time. I need not one IED, I need two IEDs, right? So let's imagine you have only one IED. The rest, the second IED you can simulate, right? Station Scout can simulate it. I will add one more. One, I will load to this. The other one, I will tell Station Scout to simulate. To see my goose is working or not, to check my specification already offline. Because I had a goose, right? But I was not sure if this goose is correct or not. Maybe I made a mistake by the engineering already. I can check this. I have just one physical IED. Sorry, it's slow. Okay, now I have two IEDs. There was no match found, but now I can select the first one for VCU, second one for way control. And you see here, it's very small, but I will make it larger. It says, I can do something. Yeah. Out of 10 logical devices, I matched 9, but I couldn't find one equivalent logical device. That's good, yeah? 90%. This, you had 3, I had 2 of them matched, 1 is not matched. Let's see, we can fix this, I think. I open this base controller, I see a red, and red is the root. Oh, the boss is not matching. What do we have in the root? It was LPHD only, right? Actually, Siemens is not start at this point. He should have. Do you remember the default data model of Siemens? They have application logical device. That's the boss. He couldn't find it. Actually, he could find it. Yeah. And he says LPHD no match found. This is funny. Algorithm is not so good in Dixie here. Why? It's LPHD 0 and I have LPHD 1. He could do this, yeah. You need to do some more. But now I made some manual work here. I match LPHD 1 with LPHD 0. It's okay for me. So you see all checks, everything match, match, match. Only I have some problem here and here. Let's do what is. So these are the descriptions where he tries to match. He couldn't find LTMS. What was LTMS? Time supervision. But actually he has it. You see? LTMS 0. Just the suffix is not matching. Yeah? Come on. Can't do that. In the measurement I have a problem. Yeah? This is my mistake. I tell you why. Because what he couldn't find is this total watt. Yeah? Maybe this is not in the file. Yeah? This is just a. And the problem is phase to neutral voltage. I defined neutral. This is funny. You have phase to neutral and neutral voltage. Yeah, this is not possible in this. You need something else for this. You need another logical node. Okay. So with that, if I click this, then my dream ID is 100% matching. Okay. You can go to protection, do the same. There is no match 0. Root is again not matching. This is no big problem. You can select LPHD and then go to LPHD. Now it's matching. There's a problem with overcurrent maybe? No, it's 100% matching. What about distance? Oh, teleprotection, we couldn't find it. But actually it's there. Yeah. You need to do some rectify. And in the diagnostic, what does LTMS again? Okay, good. Now it's also matching. So he creates the ones that's not available. Okay? Actually created, don't look what it says. It's not perfectly working. The thing is, now I will check my ID here. So I will close everything. I will connect to this ID, but this is now factory default. And you see, its name is SIF. Yeah, everything is factory default. And look at the logical devices, logical node names, they are also default ones. You see, they are all Siemens default one. This was not my data model, right? This is the factory default one. I want something not like this. I want this. And then I need to click adapt data model. Okay? I will click adapt data model and hide the Siemens thing and import everything. I say import. Now Siemens is adapting this data model to my desired data model. Okay? He is now doing in the background this job. Okay, let's do if it could make it or not. So, sometimes it breaks. I don't fix it.
Easy. Easy.
Omicron is alive.
Easy. Oh.
Siemens is Yeah, okay. He was working in the background. He should tell me that. But now we look to the IEDs if he could really adapt the data model or not. So we go to the first IED, for instance. Now the name is changed. It's BCU. Just copy and paste here that you know who is who. And then we go to data model structure. I make it bigger. Now you see the name is now changed. Diagnostic. This is our logical device. This is measurement. This is our. Okay. The mode though it didn't change because Siemens cannot change it. Yeah, there are some compromises. As an auto-regular, this was our. Yeah, and then if you open it up, you will see this was also our logical node. This was also our. Yeah, synchro check root. Remember the boss root. It could adapt this. Okay, and let's look to distance or protection. This is protection, the name looks good. Let's look to the data model. What did we have? We had some diagnostic distance and we had 3 zones. You remember zone 1, zone 2, zone 3? Teleprotection. So he could do the thing. Yeah, good. Overcurrent. 2 states. Stage 1, stage 2. Yeah, good. Okay, now the last step is loading this IED to a physical IED. Okay, so our dream comes true. Now we can really create a physical IED that we have wanted to have. We can load the configurations to the device. Now the device is running this. Okay, and then when we load this, if everything goes well, this takes some seconds. Is it loading? The saxophone guy is there? Okay. You can ask if this is only possible with Siemens or is it also possible with other ones. Actually, there are possibilities also in the other IEDs. The manufacturer doesn't need to use a menu item here. They can do also manual work. Yeah? Siemens has this function, maybe the other one doesn't have, but at the end they have to supply your data model. Okay? You can define the data model and give this to specification is the data model functions, right? Let's see. Looks good. Now, this is not like this anymore, okay? Now we close this IED, we connect again, and we will see completely different data model of protection. Take some time. What do you do first? You paint. So the device comes first, the data model or the 600 communication takes some time. Now it's good. You see, protection. You forget this. It comes by Siemens. Distance, overcurrent, root, diagnostics. So our dream IED is now running in the device physically. Okay, it's manufacturable. So what we dreamed is possible to manufacture. Okay. The last thing is now I have the protection, but I don't have the wave controller. And then you can go online with Station Scout. This one, you can go online to check our boost. So what do? We simulate this ECU. We don't have it. So what are we checking now? If this boost is correctly working or not. Okay. You can go online with the system. The IP is already set. We just simulate this. We try to connect to this device, which is running now. See the ID is connected, and the boost I can see. And he is receiving the boost. We can do something. Maybe we can. I don't want to take your time much, but the received boost, where is it? here. We can blink an LED maybe, simply. Let's blink an LED. If I change, this is the position, right? If I change the position, then an LED will blink. The position will come from station start. Okay, let's make a LED simple. The first LED would be closed, okay? The first LED would be closed. The second would be open. And then intermediate, third one. And that's stage 4. Okay. Very quickly, note this. Okay. This would not take so much time because it's just LED. So if this works well, and then I can change this goes. When I change this, then I should see an LED blinking. Now the ID is done. It will come in a moment. Let's see. Something to see. Open or closed or something.
Yeah.
Something blinking?
Yeah.
Okay. Now? Change? No? Is that an LED? Yeah, this one. So when I change this, it should change. I don't know which one is this. I need to look if it's QA1 or QB1. But if LED changes, let me know. Does it change? No? Now?
No.
Now?
No. No.
Are they? Should they? I don't know. Okay. I don't know why. Let's check. Normally, let's check it out. This RX position is coming from it should be CSW.